So how many of you went around your house wondering if your plants were in the right amount of sunlight or not? So how can you tell if your plant doesn't get enough sunlight? If you are wondering if it's getting enough, here's how to tell if it's not. So the plant that is not getting enough sunlight, oh yeah, my great artwork, is going to be very spindly and tall, and you're going to have long internodes. So you're also going to have some really little unthrifty leaves, small and unthrifty leaves, unhealthy. So you know there's a node at the base of each leaf, or at least you should know that. So the space between those is what we call the internode. So as opposed to a plant that might be alternate like that, we may have a plant like this. It's got very long internodes that is very tall or long stemmed, spindly, and unthrifty. That is how you can tell if your plant is not getting enough light and it needs a little bit more. Conversely, if it's getting too much light, which is really rarely a problem for a plant to get too much light. If it's too much light, it'll be a little bit shorter, stunted, really tight internodes, but usually that's not going to be as much of a problem in our house plants. So keep this in mind because we're going to come back to this at the end. So we talked about photoperiod with animals, so you should understand what a photoperiod response is. It's a chemical or hormone reaction in the body in response to the length of light. Now there are some other things that can affect us in plants other than the length of the light. It could be the concentration of the light, the type of light, for example, the wavelength. If you have a plant that's only getting a green light wavelength, is it going to grow? No, because it's not getting the red and blue it needs. So it could be the wavelength, the type of light. Now, having said that, most house lights have the red and blue, so a plant itself, as long as it's getting light, is usually okay. It doesn't have to be actual sunlight, although sunlight is natural, so it's probably the best, but it can go with just regular light. But anyway, so there's different things, and also how strong is the light. So there's all kinds of things, but photoperiod is the thing we're going to really concentrate on, and that's the duration, the length of the light. Now, plants and animals don't really have just a need for a length of light. They actually have a need for dark. Can you imagine if we were in the light all the time? It would be really difficult to get the sleep we need. It would be difficult, and if we don't get the sleep we need, we make cortisones that make us fat. So sleep is very important. Dark is very important. For plants, it's very, very important as well. So we have short day plants, which would be long night. Okay, we know that happens in the fall and winter. We have long day plants, which would be short night. We know that happens in the summer, the spring. And then we have day neutral. So what that means is a short day plant flowers when the days are short and nights are long. Can you think of a flowering plant, a plant that's very popular that flowers during the fall and winter? Think about football season and holidays. So the couple of ones that come to my mind are chrysanthemums and poinsettias. So if you put them in a greenhouse and somebody flips the lights on and just leaves the lights, forgets to turn them off, and those plants think that it's going to be long days, they're not going to flower. So then you're going to have a lot of vegetation. And if you want to grow vegetation, that's a good way to do it. But they're going to have a lot of vegetation and no flowers. Also, think about if you're growing them in a greenhouse and your greenhouse is right beside a road and cars are just coming down that road at night shining light in your greenhouse. That is something we would refer to as light pollution, and you can understand how that's going to affect your plants. You're not going to get those pretty flowers. You're not going to get as many flowers. You're going to get a lot more vegetation without the flowers, and nobody's going to buy your plants. So you can see how light pollution and how we can artificially stimulate different things using photoperiod. So long day plants would flower during the long days, short nights, spring and summer. And then day neutral plants will flower independent of light. They have other triggers. So we also talked about with horses how we can artificially change things. Plants, same thing. We just talked about it with the vegetation. So now that's a pretty good overview of photoperiod. Now let's talk about phototropism. Yay, this one's really fun. This is actually my favorite photo thing to talk about. Phototropism. So tropism refers to movement. So if photo is light and tropism is movement, phototropism is movement in relation to light. Some of y'all already know that your plants grow towards light. You probably heard that as an old wives' tale, or you've heard that. But it's true. Plants do grow towards light. And then if you've ever driven by a beautiful field of sunflowers, you know sunflowers actually move throughout the day with the sun. And it's really cool. So in the mornings, they'll be facing the sun one way, and then at noon they'll be up, and in the afternoon they'll be this way. So sunflowers move with the sun during the day. And why do they do that? It's kind of magical, isn't it? But let's talk about the mechanisms that make that magic happen. So here's your sunflower. All right, that looks just like a sunflower. There we go, there's the sunflower seeds. All right, let's give it some sunlight. There we go. All right. There is a hormone in the plant called auxins. Now, auxins is very important, and if I ever ask you a question about hormones and you don't know the answer, just guess auxins. Auxins is a really important hormone for the plants. Auxins is going to be growing in the plant all the time. Now, the sunlight breaks down auxins. So, if the auxins is growing in the plant all the time, but sunlight's breaking it down, it's going to actually build up in the shady side. Now, what do auxins do? Auxins promote growth and cell elongation. So if your auxins is promoting growth, then this side of the stem is actually going to grow longer and faster than this side and actually tip the plant that way towards the sun, because that's longer on that side. Now, auxins breaks down on its own in about 2 hours. So in about 2 hours, all of these auxins are going to be naturally broken down, and the sun will have moved and will be breaking down auxins somewhere else. So when the sun is up here, it's going to be, the auxins are going to be equal in both sides of the stem, and so the plant's just going to be up. When the sun moves over here, the sun is going to be breaking down the auxins here. So where are they going to build up? They're going to build up in the shady side. They promote cell elongation and growth. So this side's going to grow longer and tip the plant towards the sun in that way. So, yes, it's still magical, but now you know the trick behind the curtain, how that magic happens. So, I hope you understand photoperiod and phototropism. Go check on your plants if they're tall and spindly. Yes, remember I told you to keep that in mind. So, tall, spindly plant. With what you know now, here's our plant that's not getting enough sun. Why is it long and spindly? Because it's not getting enough light to break down the auxins, and so it just keeps building up auxins and growing taller and taller. So it's not getting everything it needs. It's not getting the red and the blue light spectrum for photosynthesis, which makes the plant food. So the plant's kind of starving to death. Because he's starving to death, he's not making very nice leaves, but at the same time, the auxins are building up and just making him taller and longer and more spindlier, and hoping that he can get to some sunlight. So go check on your plants, see how they're doing, and I will see you next video.